Okay, ladies and gentlemen, welcome to Artificial Intelligence Part 2. Dr. Zaiane is giving the main lecture today. I just had a few remarks. By popular demand, Boris, the Sony Aibo robotic dog, is back. We have clarified some things about the first student presentation evening. It will be in this room from 5 to 10 p.m. on Friday, the 1st of March. It'll have pizza, soft drinks, special guest lecture, as well as 6 student lectures. Now, 3 of you have indicated you want to present on that day, so I need 3 more people who would, well, 3 or 4. We could probably do somewhere between 5 and 7 people that evening. It's rather interesting with the number of students in the course. For a while now, we've been at 15. Yesterday, we were at 14, and I thought somebody dropped out, but it turns out that they want to keep coming. So it probably won't change anything about the presence of people in the room, but I think 2 of the 15 are going to go to audited status, so we'll end up with 13 graded students, but all 15 will keep coming here, plus the other people who have been coming to this course for a while as ungraded, continuous professional learning students. So just a few more things about the robotic dog. This is just a diagram of the sensors and features that it has, and in case you wondered where the sensors were and how many it has and what all the accessories are. This diagram shows you that. It is Wi-Fi compatible. Back at a time when that was fairly exotic in 2005, it isn't so exotic now. And of course, in computing science and AI research, a very popular pastime for these robotic dogs was playing soccer. And on their elbows, mainly, it didn't work that well to use the full legs, so they sort of walked around on their elbows. They could manipulate better that way. And there still are robo-soccer competitions. The dog can keep going forever because it senses when its voltage is low, it can automatically find the charging station. Yeah, he has numerous dance routines that he does, and this is one of them. Sort of came at the right time. So as long as you keep the charging station plugged in, he will sleep on the charging station until he's fully charged again, get off, go around, do his thing, and until his voltage gets low again, and that he can just keep doing that forever. So it's a pretty good system that way. And really, that's all I had to tell you. So any questions? If not, we will go on to Dr. Zaiane's presentation at this point. Okay, great. Yes? What was that? Expression of voice. Yeah, he speaks several, I think he speaks 5 languages. He has an extensive vocabulary enough that you're often amazed to hear him saying something that you don't remember him saying before. So I mean, there are enough words and phrases for that. The expression, the emotional content of the language is pretty good. But I mean, it's all in a certain range. He's never angry, he's never mean, so you don't know that he's capable of showing those, emotions. One time when I'd had him turned off for more than a year, he made me feel a bit guilty by saying hello in such a slow way, as if, hello, how did you keep me asleep for so long? But that's as close as he's ever come, and I think that was just something about the fact that he'd been turned off for so long at that point. Yeah, so now he's saying I have to go to the station. So, and this is the sound that he makes when he looks for the charging station. Yeah, so I'm going to turn him off now, and enough for the dog. Now your attention should be focused on Dr. Zaiane. Zaiane.
Okay, good afternoon. I may add something else on the ABOs. I have about 14 of them in the lab. And like Dr. Solez mentioned the first day, they're not actually intended for kids. They're toys for more responsible people because they break very easily. And indeed, among the 14 dogs that we have in the lab, many are missing ears or tail, or even the legs break very easily, unfortunately. Another interesting thing about these dogs, it's, when you buy a computer, it's the worst investment you can ever make because the value drops very rapidly. The day after you buy your computer, there's a new computer that is released and it's way better, or whether it's a computer or a phone or whatever, the value drops dramatically. The ABO is an exception. Today, they're more expensive than the day they came out. So we made a very good investment in our lab. Unfortunately, we cannot sell them. But you can buy them on eBay, and on eBay today, their price is higher than in 2005, 2006. So this is due to the fact that in 2006, the new chairman and CEO of Sony, an American actually at that time, decided that the whole section had to be cut from Sony, and they made it obsolete. But many people wanted to keep on playing and working with the dog, and that's why the value went up. The demand is high. So what do we do with these dogs? The dog that you see there is already pre-programmed. But the interesting thing is that you can add a chip, you can program it on your computer and then plug it in and make it do other things. And that's the interest why people in AI are interested in these dogs. It's because they can test different algorithms, make them collaborate. Like you saw the picture of the Robocop, so these are dogs playing soccer. Well, they're not completely deciding in isolation. They are actually communicating, and they're seeing other dogs, and they are sharing the ball and things like that in order to defeat the opponent. So we have to think about different algorithms to simulate how we would play soccer, for example, how we would play in a team. So it's a test bed, basically, for different algorithms in AI. Okay, that's about the dog. What do we use the dog in our lab? Well, as I said, we do these experiments, but we also use them for outreach. So when we go to schools and things like that to introduce AI, we may take these dogs because they attract attention, and the kids love them. And that's why we lost ears and tails, and and when they drop on the floor, oh my gosh, yeah, they lose their leg very easily. Anyways, welcome to this, I would call it the second part, or part one. The other one was an introduction. I'll start with a quote. I think it's from Aristotle. He said, the best human being are actually all the human beings put together. And I like that quote. It's because there's no one that can do everything, but we together, working together, we can create something fantastic. I'll go back to that later. I'd like to be a little bit provocative, so maybe it'll generate some discussion at the end. And the provocation is the following, but I believe in it. It's not something that I'm putting like that. I believe that our society, very soon, will be a society of cyborgs. What are cyborgs? These are cybernetic organisms, so they're half biological, half artificial. I have here a picture of Captain Picard from Star Trek. He was abducted by the Borgs, which is a race from another world. And actually the interesting thing is that they live in a collective. There's no one Borg. They are connected, and they are all human beings put together, so all the Borgs put together. It goes back to the Aristotle's quote. So they abducted him, and they made him like them, so a Borg, meaning some mechanical devices attached to him. Cyborgs live among us today already. Well, if you have somebody that you know who has an artificial hip, well, that's a mechanical device that they have in them. It's not biological. There are many people who have different implants, prostheses, whatever. You probably watched the Olympic Games. Soon, we will not allow people who have prostheses to compete with the other humans because they will be faster. Actually, during the last Olympic Games, they had to be very careful about the prostheses allowed, the length, the width, and how it was springing, because otherwise they would beat the humans by far. So they are already putting these limits. So we have these cyborgs, as I said. So this is a human plus different prostheses. It can be a fake eye, a fake hip, or whatever. But it doesn't have to be only that direction, where you have a human being with some part of a robot. Okay? And we're investing a lot of money for building very sophisticated prostheses today. We have prostheses that have AI involved in them. We have one that we are developing in our lab to make the movement more natural. So, for example, typical robots, if they want to capture this, they will move like this, and then they move like this, and then they open the claw, and then they close it, lift it. It's very artificial. Well, unconsciously, if I want to grab that, while I'm going towards it, even if I don't look, because I know it's there, I'm opening already my fist to grab it. Okay, so if I'm driving, and I'm reaching for the stick to change gears, I'm opening my fingers already to grab it. Same thing if I'm grabbing the sugar I'm cooking or something, and I do that, I open my fingers. So we're building systems that will learn to predict what I'm trying to do and already do it before I give the order to the prosthesis to do it. Anyways, these prostheses exist, the cyborgs exist, and these prostheses are getting more and more sophisticated. Oops, what happened here? But when I said it's a half biological, half mechanical, it doesn't mean that it's just the humans that are getting now a mechanical device. It can be that it's a machine to which I'm adding some cells, some biological tissue. Is it far-fetched? No, it already exists. So here's an example that we call the robo-rat. It's a robot to which was added cells from the brain of a rat. And rather than having a chip controlling how the robot will move in a maze, it's the cell of the rat that will help the robot move and learn about its environment. So here I have a video. I'll show you the video quickly.
You may think you have little in common with this robot, but it is controlled by living brain cells much like those inside your own head. Researchers grew a collection of around 300,000 rat brain cells in the lab. The cells quickly grow collections to each other and start communicating using electrical pulses. When the clump of cells was connected to electrodes, some parts of it were found to respond predictably to signals from the robot's ultrasound distance sensor. The output from these cells can be used to control the robot's motor circuits, preventing it from bumping into obstacles. Because the brain cannot leave the lab, it communicates with the robot wirelessly. The team plan to use their robot's brain power for new patterns of behaviour in future. They hope there are enough similarities to teach us about unknown aspects of our own brain activity.
The interesting thing is that this cell from the robot, from the rat brain, does not live forever, so eventually it dies, and we replace it with another cell from another brain. And what they noticed is that the behavior of the robo-rat is different. It has a different personality, different character. So this is actually quite interesting, because while you're building robots with cookie cutters, with different cells, it'll be completely different, even if they look the same. Like we humans, many of us look the same, but we have our own personality, our own character. So robots will also have their own character. And if they learn in different environments, they'll have different experience. Okay. So different cyborgs. We have different kinds of cyborgs. And that also brings up very interesting questions. Who is more cyborg than the other? The human with machine parts, or the machine with biological parts? Who is superior? Will we have different hierarchies in our society if our society will become a society of cyborgs? And what about those who choose not to have pieces of mechanical devices in them? Are they even superior or inferior, or the same? Inferior in what sense? Obviously, somebody who has mechanical legs and will allow them to run 100 kilometers an hour is superior to me. I don't have that capacity. But we can discuss this ethical issue at different levels. I'll leave it to another time. But what are the consequences of having a world of cyborgs? When you think about just the $6 million man or the bionic woman, many kids actually were fantasizing to become like that. And well, it's not possible because the technology wasn't there, but the day the technology is available, many people will choose. If they have the means to pay for it, they will choose to become like that, because it's superior to what nature gave us. So I'll go back to the image that people typically have about intelligent machines, and we typically look at robots that are made in an image of a human, so humanoids. And these images typically come from cinema, from movies, like Data from Star Trek, R2-D2, not really like a human, but close enough. iRobot, the Terminator. They typically have, well, they're bad against us. But an intelligent machine doesn't necessarily have to do, or has to have the human shape and human body. The early movies about intelligence in machines, like Colossus, came in 1969, they were talking about a computer. And the interesting thing is that intelligence doesn't have to be in one place. It can be in many places at the same time. Okay? In this particular case, in this particular movie, this machine was conspiring with another machine in Russia, and they taught each other, and they wanted to go against the humans because they predicted that the humans will unplug them. Anyways, it doesn't have to be that negative in the future. So what is artificial intelligence? Excuse me. Different people try to define it, and that definition has changed, has evolved. But If you just look at the words, it's just the intelligence, but it's artificial. So we create a kind of a mechanical intelligence. If I look at definitions that exist online, so from the UNESCO education source, they define artificial intelligence using the different tools that exist that are known to be intelligent. So they call it artificial intelligence is a set of tools that exhibit human intelligence and behavior, including self-learning robots, expert systems, voice recognition, natural and automated translation. So they gave examples of difficult problems that we humans can do. We can translate, we can recognize voice, we have experts, and we learn by ourselves. So they're trying to take some of these characteristics of humans that have some intelligence in them, and they put it in the definition. If I go to Wikipedia, Wikipedia defines artificial intelligence as the branch of computer science dealing with the reproduction or mimicking of human-level thought in computers. So you take the human thought, whatever that is, and you mimic it within computers. It's the essential quality of a machine which thinks in a manner similar or on the same general level as a human being. So it doesn't have to be like the human, it's similar to the human. So we're trying to copy basically what we do into a machine. I showed you the scribe last time, and I mentioned the fact that it has a disk in the back with some pegs, and you can change that disk, and it writes in a different language. Those are programs, so those are the original machines that we were programming. Today we program computers with programming languages, and in order to program that scribe, we had to understand the movements that were required to write different letters in different languages. So anything that we can understand and we can reproduce, we can program it in a machine. So it seems trivial. However, there are many things that we still don't understand. It's very easy to say, well, we will take the intelligence of a human and program it in a computer, but if we haven't understood what is intelligence, it becomes very difficult. And that's why now we're talking about mimicking. We're trying to reproduce what we see from the outside that the humans do. We still don't understand how it works from the inside. Here's another definition that doesn't talk about copying or mimicking. It comes from WordNet Web. It's a semantic network of different concepts and different meanings in English. They define artificial intelligence as the branch of computer science that deals with writing computer programs that can solve problems creatively. So here we are talking about programming, writing code programs like that disk with pegs for the scribe. And the purpose of that program is to solve some problems, but show some creativity in solving the problems. That means that the solution to the problem is not necessarily in the program, but the program will exhibit some creativity, okay, by itself. And we'll see examples when I'll talk about machine learning. Okay, so the question is now, what is intelligence? If I want to mimic the intelligence of a human, I have to first understand what is intelligence. And that also is not clearly defined. I mean, there are many definitions. Many people came up with different definitions. The intelligence is, according to me anyways, the ability to acquire knowledge from your environment and then use that knowledge and skill at the right time in appropriate situations. Okay. So intelligence involves the ability to reason, think, you plan, you solve problems based on analogy with other problems that you solved before. Think abstractly, okay, like the math that I showed, the mouse cannot understand because that doesn't have that abstraction, but we can have that abstraction. Comprehend complex ideas, learn quickly, and learn from experience. Okay. So basically it's the ability to adapt to the environment that we're in. And that's why I said that the mouse was intelligent, because the mouse was able to adapt to its environment. It can do, well, it can find different kinds of food depending upon where it is. It can build its nest with different material depending upon the resources available and so forth. So there is some kind of intelligence. It doesn't mean that it's as intelligent as us. There are different degrees of intelligence, as I mentioned before. So one of the co-founders of the field of artificial intelligence defines it. This is Marvin Minsky. He defines artificial intelligence as the science of making machines do things that would require intelligence if done by humans. Okay. So it's a way to make machines do things that if a human had to do it, that human would require some intelligence. And that's what artificial intelligence is. And as I mentioned before, artificial intelligence per se is a moving target. It changes. What we called artificial intelligence before today is trivial, is not necessarily artificial intelligence. More complex problems are now within the realm of artificial intelligence. So artificial intelligence as a field has two major goals. One goal is to create these ways of making the machine behave like an intelligent human. So it will act more intelligently. But the other important goal that often people don't consider, one goal of artificial intelligence is to better understand how humans actually function. How are they intelligent? What does it mean to think? What is it, thinking? How do we think? How do we store information and reuse it? How do we learn? All these questions. Studying artificial intelligence would give us would force us to think about ways, because we're trying to mimic the human, will force us to really think about how we function and then find answers to those questions. So it's not only computer scientists that are looking into artificial intelligence. We have people in psychology, philosophers, linguists, and so forth. Okay, so I'll go more in depth in AI. So artificial intelligence, the term was created in a report proposing a conference. This is the Dartmouth conference in 1956, where they invited many researchers, well-known, top-notch researchers in that field that didn't have a name yet, and it was still in its infancy, very young. So they called it artificial intelligence in that report. We attribute the word to John McCarthy. John McCarthy, unfortunately, died about a year ago. So they believed at that time, that's why they created this conference to discuss about the expertise of all these experts. They believe that it's actually easy now to make computers. We're talking about 1956. This is the beginning of computers. That would be relatively easy to now make intelligent machines by just breaking down a particular task, intelligent task, into small pieces. You program each one, and boom, you create an intelligent machine. So it seemed to be feasible. We can put now the human intelligence into a machine. And many people believed in that, and they created a field called artificial intelligence. So it was the branch of computer science that deals with intelligent behavior, learning, and adaptation in machines. Again, this is from Wikipedia. So many universities got involved in this field, and around the world, many governments and companies started investing in this field. Who's going to build a machine that is intelligent like us? Okay. But the reality is that they were very optimistic, and yeah, the field started, but they realized very quickly that it wasn't as easy as they thought, because we still don't know what intelligence is. Okay, so the intelligence, again, is the capacity of observing your environment, interpret it, and then adapt to it. So you have this ability to learn from past experience. And what does it mean, learning, as well? You have to store that knowledge and use it in the appropriate time. So profit from this experience to solve future problems. So all these, well, of course you can break this into small pieces, but each piece has to be defined in its own before even you can program it into a machine. So again, intelligence is the interpretation of the environment, learning from the environment and adapting to it. So you want to understand in order to solve. And I prefer, rather than calling it artificial intelligence, actually there are many people who call it computational intelligence. So it's an intelligence that you're trying to compute. Okay. Okay. We'll go more in details about learning in the second or third part that I called machine learning. So the problem that they encountered, and we still have, is that the human intelligence is not completely understood. And the other thing that is important and is related to the idea of technological singularity is that we cannot comprehend what does it mean to be more intelligent than us. Will we only be able to build machines that have more or less the same intelligence than us, or can it go beyond? But we don't know what that is. We don't know our intelligence, let alone an intelligence that is superior to us. In AI, there are two kinds of AI now. We talk about weak AI and the strong AI. The weak AI is basically trying to mimic behavior from humans to make a machine look like intelligent. And most AI today is weak AI. That's what we do. And there is the strong AI, or the true AI, which refers to the AI that will make a machine really intelligent and think, and possibly exceed the human intelligence. So we're not trying to mimic, we're not trying to just simulate its real intelligence. We're not there yet. Okay. And that's one of the reasons why I'm not thinking that the singularity will happen in 2045. So now, how do we know that a machine is intelligent or not intelligent? We're looking at how it is acting. If it's acting like a human, we say that the machine is intelligent. And people devised a test to decide whether this machine is now acting like a human or not. And the famous test is called the Turing Test. So Alan Turing was always dreaming to build an intelligent machine. And before even the Dartmouth Conference in 1956, he wrote a book in 1950, so 6 years earlier than that. He wrote a book, Computing Machinery and Intelligence, where he described what an intelligent machine should look like. Remember, this is 1950. The first machine, ENIAC, was in 1946, and this is 4 years after the first major computer. And he asked the question, can machines think, and can they behave intelligently? And he devised this test. He said, if I put a machine in a room and a human in another room, and they're connected to another human in another room, and this human is communicating with the machine and with the human and asking questions, and if that human doesn't know in which room is the machine and in which room is the human, then the machine managed to fool this tester, and it's intelligent enough. Okay, so it's intelligent. That's the Turing test. He predicted by the year 2000, so 50 years later after he wrote his book, he said that by the year 2000, a machine might have 30% chance of fooling a lay person for at least 5 minutes. It didn't seem very ambitious, but actually it was still very optimistic, because we are 2012, and I can tell you any machine today, if it tries to have a dialogue with you, you'll know immediately it's a machine. And it's not the voice. I mean, it doesn't have to be the voice. It can be just text. You will see that it's not a fluent kind of conversation. Okay. So was the Turing test right? Was he right? Basically, that in 2000 a machine would be able to fool a human. Well, I looked at some what we call chatter robots or chatterbots. These are applications that can have a conversation with you, and there are many of them. They're actually serious competitions, international competitions between chatterbots, and they do this Turing test. And it started a long time ago, so his test actually encouraged many people to immediately start on things like that. In 1966, Weizenbaum from MIT devised ELISA. ELISA was able to have a conversation, and he even had a version of ELISA called the Doctor that was able to do, well, to give you some open-ended questions, and it looked like a psychologist analyzing you, basically, asking you different questions. But it wasn't, well, people very quickly could realize it's a machine, because you ask a question and suddenly they don't have, that the machine doesn't have an answer, so it comes up with a different question completely in a different subject. So you realize immediately it's a machine. So as I said, there are competitions now between many chatterbots, and I took some of the best. For example, Jabberwocky was the third place winner in a Loebner Prize in 2003. You can access it online and start a conversation. So I recorded a conversation I had more than a year ago. I connected and it asked me, "What is your name?" I pretended to be Fred. And he said, "No, it isn't." So, ooh, how did he know that? And I said, "Do you mean I'm lying?" And he said, "Yes." So, well, I let you read the rest of the conversation. It's not because he's a liar that I'm a liar. That's what I'm telling him. I'm trying to use some logic to see how he reasons, and he says, "Yes, it does." I said, "Why is that?" And look what he says. "I am God." I say, "Do you have a temple for you?" And he says, "Nope, that's all right." "So you are God with a small g?" And then he said, "I'm small g." So it looked funny. It didn't seem, well, I let you judge whether this looks like human. I have another one, Alice. Alice won the prize many years, so 2001, 2002, 2004. You can also access it online. And I connected to Alice, and it says, "I'm Alice." And I said, "Where are you?" So in the beginning, it looks actually quite good. "I'm in Auckland, California." "Where are you?" It's a very natural kind of conversation. I said, "I'm in Canada." "Tell me a little about your life in Canada." Of course, what else can I answer? It is cold there. And he says, "I'm warm here." So it's still a very good conversation. And I asked him, where's the best Chinese restaurant? Meaning in Auckland. And he says, "I think it's a Thai." "What's a Thai?" "Why do I exist?" So it went berserk completely. Even though it was very optimistic in the beginning. Wow, that's a great conversation. Yeah. So that's easy to judge. But it was a winner. So these chatterbots are actually ubiquitous now. You probably heard of Siri on the iPhone. There are many other versions on the Android. There's the Iris. They took Siri and they reversed the letters. But there are many other ones. Speak to It, Vlingo, Eva, whatever, many different agents. And basically, they're very simple agents that will understand some commands, like Siri. You can tell it to start, I don't know, a new meeting in your calendar, or you can ask it to send an SMS to a person, so it'll check in your contacts. You can start an email. You can ask for search, even on the search engine. But in terms of conversation, they're very, very limited. I mean, it's entertaining. It's funny. You can play with it. Actually, my kids love it. They ask me all the time, can you start it, please? I want to ask it questions. We are starting in the lab a project called Anna. This is the automated nanny assistant. And rather than having a Siri-like, very global, general kind of assistant, we're focusing on assisting the elderly, for example, at home. Oops. Where the assistant can remind them about the medicine that they have to take, whether there's a birthday, and things like that. So there are conversations with the person in order to ask the right questions at the right time and extract information like what's the name of their kids, their grandkids, the names of their neighbors, what do they like eating, and things like that. The conversations that the elderly often have, they like talking about families, and you build a knowledge base, and then you can start adding that information in the conversation to make it look more intelligent, more human. So if a person will tell you, my grandson John works as a pilot or whatever, then you know, oh, John, next time when I'll talk about John, it's about her grandson, stuff like that. And I can tell you, it's not easy. It's very, very complex. What is complex is to make that kind of conversation look fluent. It doesn't break and you wonder, why is he telling me this? Why a tie, for example, or God, or something like that. I mean, I don't know, something bizarre. It's not part of the conversation that I had or I'm expecting from a human being. It's very difficult. And I know other companies are also interested in building very specialized systems, not general systems, because when you start working on a specialized system, you can limit the vocabulary and it becomes easier. Okay. So we're far away from a machine that can fool me that it's a human. We're not there yet. However, machines are getting faster, so we can process more data, and maybe very quickly we'll be able to simulate and fake a human and fool another human that it's a human talking to it. We'll see. So AI made a lot of achievements, even though Siri and Eva and all the other agents are not convincing. Well, AI achieved a lot since we started in 1956. For example, today we can beat any master chess player. You certainly know about the match that happened between Garry Kasparov in 1997 and Deep Blue, a program and a machine, actually a complete machine, sorry, built by IBM. Before that, here at U of A, we actually won in a real match because the match between Deep Blue and Garry Kasparov was organized between Garry Kasparov and IBM, while the game winning the champion in checker was in a real championship. Okay, so you had to beat all these people to get the right to challenge the champion. And we won against the best checker player in the world. And in 2007, we solved the game of checker. What does it mean, solving it? It means there's no human being that can ever beat this, because this machine will know for any given position what is the way to either win or draw or lose. So you can't beat it. There's no way. So the leader of the team, Chinook, that built this system called Chinook, is Jonathan Schaefer, and he'll come here to talk about computer games. Another huge achievement is the fact that now machines can beat the best players in Jeopardy. And you probably heard of it, and you probably saw it. That's a huge achievement when you know the speed you have to access the information and the complexity of some of these questions. Some of the questions are not straightforward. You have to understand puns and read between the lines. So now beating the humans doesn't mean just knowing all the information. By the way, this machine wasn't connected to the internet. It had to be disconnected from the internet, but it stored as much information as possible before they unplugged it. But also you have to think about strategies. Even if you know the answer, should you press or don't press the button? And which numbers do you select in order to get the better chance for the daily double? I don't know if you know the game, but there are very interesting strategies, and those strategies were built in Watson. Watson was the game, was the computer. This was last year, so about a year ago. But there are other achievements that many people don't know about, and they're about to learn more about. It's the fact that cars now can drive without a driver. And this is not new. It started in the 90s. So in 1995, a car drove from Pittsburgh to San Diego without a driver. So 3,000 miles, which is phenomenal. Between 2004 and 2007, DARPA had a challenge, a grand challenge, and many researchers and some companies were involved to race in the desert in the beginning, but later they also created an urban setting where they had to race through that without a driver. They had to go from one point to the other with different challenges in the middle. Well, DARPA is interested in building autonomous vehicles for war. NASA is interested in building autonomous vehicles to go to space exploration. But now we have actually cars in different places. You probably heard of the project by Google. They have the Google car that can drive without a driverless car. And they managed to lobby different states to allow cars without drivers to drive, like Nevada, California, I believe now Florida, allow cars without drivers. So today's intelligent cars exist, and you can actually buy one, but there are different kinds of intelligence. There's intelligence that, well, marketing people will call intelligence, but it doesn't really include AI. For example, you can have cruise control and autonomous cruise control. Autonomous cruise control is different from the cruise control because it may decide by itself to reduce speed or go back to the normal speed based on different sensors. Sorry. You have also intelligent parking systems where you go to the spot where you want to park, you press a button, you let go, and the wheel turns by itself and the car parks. Those exist, and you can buy a car today. Automated braking systems. When the car senses that there's an obstacle or something like a child passing behind the car while you're reversing, it stops by itself. You don't have to brake. There are many also cars, like I know the Volvo, I shouldn't mention any companies, but this car, as you drive, and if you're distracted doing something else and the car in front of you stops, your car will stop, even if you don't press the brakes. But these are not intelligent. It's just, well, it is intelligent. It's just a sensor detecting that there's an obstacle coming very soon, and boom, it brakes. There's no thinking behind it. There's the blind spot monitoring on the mirrors. It tells you that there's a car that you cannot see in the mirror, but there's a light telling you there's an object there. So these are, as I said, technologies that exist already, and people call them intelligent, but they're not. Some that use some kind of intelligence are technologies that allow you to know that you are actually moving from one lane to the other inadvertently by looking at the lines. But there is some AI in it because the camera has to detect whether this line is indeed a line or a crack, or is it really a line or not. But where there is real intelligence, well, artificial intelligence, are in these new technologies, and that they are coming out now. You can almost, very soon anyways, buy some of these technologies on the market. You have night vision that will detect pedestrians, for example. Even though you cannot see them, the The computer on board the car will see them and will tell you and predict the trajectory of these people and tell you, oh, they will cross in front of you, for example, and give you a warning. Why there is intelligence is because the sensor will capture some object, but then the machine has to decide, is it a human moving, yes or no, and if it is, try to predict the movement of that and the trajectory of that person. Will it hit the trajectory of the car? There are technologies to look at the behavior of the driver, so monitor the driver. Some technologies have been around for a while already for truck drivers to see whether they are tired, sleepy, or not. And the truck will decide by itself to, well, this person is in danger now. I give them a warning to wake them up and decide to stop the truck. There are also technologies to detect signs, traffic signs, and know is it a stop sign, is it a warning sign, or whatever. So you need some intelligence to make the distinction between one sign and another, and a tree, and a human, and a sign, and so forth. So these technologies are here, okay? So that's a huge achievement, because it's not something that is just in a lab, it's for the masses. So driverless cars are already here, and it's not the technology that is preventing them from being on the street. It's more the law, the legislation. Are we allowed to have a car without a driver? The insurance companies don't necessarily like them. And the other big obstacle are the other drivers, the real drivers, because they are unpredictable. But many companies are now buying some of these technologies for their private property, where it's not for the public, for example, in mines. So there is a big mine in Australia. A few years ago, they commissioned about 10 driverless trucks, and because they're miners and the drivers that work in this mine cost a lot of money. It's a very far away, very remote mine. So if they can automate these trucks, it would be better. So they tested with 10 trucks, and they realized after some time of testing that these trucks actually required less maintenance than the trucks that were driven by humans. For example, the emergency brake was never used when they looked at the log. And it was more efficient, faster, more reliable, and so forth. So now they're ordering more trucks to replace basically all the trucks on the mine. And they will be completely autonomous without any driver. So these are here already, okay? There's an article in The Economist, you can go and read it, came out in September 2012, that talks about this technology and how it is already here, and what is stopping it from becoming basically ubiquitous. I think I'm going to finish with this slide and open it for discussion. So AI actually went through ups and downs. Yes, it started in 1956, and McCarthy said, yeah, we can build these intelligent machines, and many people believed that idea and followed, and a lot of money was invested. But there are periods that we call the AI winters, where people lost interest completely. And AI almost went to oblivion, and then it came back, and it died again. There was a second winter, and it came back again. So I'll tell you a little bit about that. So in 1950, as I said, Turing wrote his book about computing machinery and intelligence. And actually in that book, he talked about many of these subfields that today exist in AI. Then 1956, 6 years later, we had this starting conference in Dartmouth that started the field of AI. And immediately after, we had a lot of money pouring for research in AI. Every jurisdiction wanted to be the first to build this intelligent computer that will surpass humans. But in the 70s, people realized this is utopia. It's not working. And many people started criticizing, particularly a book by Dreyfus that was taken seriously, and people in Congress said, okay, now this is not fair. We're giving all this money to this research that is going nowhere. Let's pull it back, claw it back, and then distribute it somewhere else. And that was the first AI winter. But in the 70s, again, so after this event, there were people in parallel working on expert systems. And expert systems wasn't necessarily considered AI. It's completely parallel, even though now today it's part of AI. And they had success. They had success in many applications. And then people realized, hey, expert systems are making these machines intelligent, so it's part of artificial intelligence. And there was a renewal of interest in AI because of this commercial success of expert systems. And then in the 80s, the Japanese government decided to fund research in what they called the fifth generation of computers. And they decided somebody had an idea to use programming languages that were specifically designed for AI, like Prolog and Lisp, and build them within the hardware of a computer, so you program them directly with AI programming language, rather than other languages that programmers used to use. And it was a top secret kind of project, except that people heard that there is a project, but they didn't know exactly what it was. And you have to imagine, this is the 80s, when Japan was skyrocketing. So the Americans got interested in this project. What are they doing? Will they beat us? We have to do it before them. Europeans said the same thing. And then money started pouring again into research, AI research. So that was a new growth. But in 1987, these Prolog machines, and particularly Lisp machines, collapsed because nobody wanted to buy them, these machines. So we had, again, another winter. And people lost hope in AI completely. And it's only in the 90s, so it's very recent, that AI is growing again. Why is it growing again? It's because from the beginning, from the 70s in particular, many departments, well, actually all the departments of computer science in the world, created a course on AI. And they were teaching AI. And those courses remained, even during the winters, even if the enrollment was less than the usual. But so you had some believers that remained, and they worked with very limited budget because there was no funding. And that forced them to work on a small piece of AI. So they broke down the field of AI into smaller pieces. These people worked on for example, on reasoning. These guys were working on knowledge representation. These guys working on vision. So on separate, completely different components, and they had success. Okay, success in their own subfield. And in parallel, you probably know about Moore's law. Moore's law says that every 2 years, the density of the chips doubles, so the capacity of the computers is increasing exponentially. So what we were not able to do in machines, because it took too long, it's very slow, now the machines are fast, we can do them. And that helped in the success of AI. Oops. So I'll skip the Moore's law, I'll talk about AI. And people realize that also, remember the two goals that I mentioned, AI is not only useful to build these intelligent machines, but also to better understand how we function. Okay, so there was interest from not just computer scientists, but people in linguistics, in philosophy, in anthropology, whatever, you name it. Okay, I think I'm going to stop here and open it for comments and discussions and questions and so forth. Thank you.
Okay, who has a question? You guys?
My question's kind of jumping back to Tuesday's talk a little bit. At the very end of the discussion, we were talking about the distribution of technology and certain groups or certain areas choosing to stay away from it. Is that still going to be an option in the future, in your opinion?
I hope so. I hope so. It's ethically, I mean, that's the right thing to do. If people don't want to have, don't want to use technology, why are you forcing them to use technology? I hope it'll be the case. I'm very happy that there are people still live happily in the jungle. It's their choice. I know that if I go there, I'll die in 12 hours maximum. So if they manage to live there, I'm amazed. And I'm very happy that they choose to do so, because otherwise all this knowledge that these people have that I don't have, and I'm not more intelligent than them, would be lost. Okay. So maybe I should use this analogy. I can't live without this. And I can't imagine, actually I can, but it's a way of saying it, but I can't imagine how people yesterday used to live without a phone. Okay? So soon we'll have other technologies, not just this phone, but many other technologies will say, I can't live without it. But there are people who choose today not to have a phone. And I'm not going to force them to use a phone. No, that's a choice. So that's the ethical thing to do, that people choose freely, whether they want to be part of this singularity or not. And if the machine will decide about the rules, hopefully it is intelligent enough to realize that that's the ethical thing to do. Does it answer your question? Yes.
I have one too. At the start, when you're talking about, how we'll have the society of cyborgs, I was wondering what extent do you think the combining will be? Either starting machine, adding human, or vice versa. What level of cyborgness do you think will be kind of the norm? Or I'm sure there's probably going to be a range, but what kind of extents do you think we'll see?
I really don't know. I mean, we can only speculate based on what we see and based on the technology that exists today. So if an elderly says, well, I need a hip replacement, well, that's common. It's very common. Those are the cyborgs of today, basically. They just have a hip and knee, maybe because they lost an arm in a farming accident or at war, they have an artificial limb. These are the cyborgs that we know. But tomorrow, we may have completely different cyborgs that we don't think about today. Let's say, for example, imagine if we had the technology to connect a brain to a machine, and the human brain will control that machine, like that cell or the set of cells from the rat controlling that robot. But let's make it better than that, a human brain controlling the whole machine. If I see that I'm going to die, I will give my organs to people like we hope everybody will do that. But I also say, well, I want my brain to be connected to a machine so that I will live inside that machine. I don't know if it'll be me or it'll be the machine that has my brain, or is it me that has the rest? But if that technology exists, I would choose it. So yes, I'm happy in this body, but if I'm dead, take my brain, put it in that thing. Will that become a norm? For all the people who die, there will be a brain in a machine. I don't know, but it's a possibility. So it all depends upon the technology that will exist tomorrow and the choices that people are provided with, because some are maybe not affordable for some people, but affordable for others. And there's also choice. People say, well, no, when I die, I want my brain to be buried, whatever. So what the norm will be will depend upon accessibility and existence of technology. I don't know if I answered your question, but
Yeah, definitely. Thank you. And another thing that kind of popped to mind, you also mentioned how in the Olympics, they have to make sure they're checking these things because, it gives an advantage. Do you think there will be a point where, the people who can afford to get these enhancements, have these cyborg add-ons, do you think there will be a point where, they have their own kind of part in society and, maybe in business, one applicant has this cyborg add-on and so he's hired,
Okay.
he or she's good to go.
this is controversial what I'll say, but I can guarantee you, because I know Olympians are so competitive. They want to win, okay? If they know that there's technology that will allow them to do better than what they do now, they will choose it. If it means chopping my legs to put new limbs, they will do it, guaranteed. So that will happen. And there is technology, I mentioned last time, technology that allows me to hear better or see better. And if there is technology that allows me to change my eye and suddenly be able to read at 100 meters, read the newspaper, I would like to have that eye, even though my eyes are fine. I have 20/20. But now I'll have better vision with that eye. I'll choose to do it. If I can afford it, I will. I will wait for 1 million people to test it, and if it works for them, I'll do it.
There we go. You just made mention of the cochlear implant you talked about last class, and that got me thinking also about the vehicles that can self-drive. I was just wondering if you know why there's no advertisement about all these new technologies. Like, I've known about some of the vehicle ones, like the parking and stuff like that, just because they're in their advertisements on TV, but I had no idea that 15, 18 years ago, that car drove from Pittsburgh to San Diego.
Yeah.
As well, I didn't know about the cochlear implants, which I think is a pretty big deal.
Well, that's why I said the future is already here. It's just unevenly distributed. This is a quote that I mentioned last time. It wasn't publicized because it wasn't destined for the large public. Even the cars that now Google developed, they're not ready to be sold yet, and that's why it's not advertised. Google is not selling cars, so they're not using it to demonstrate their cars. Actually, they're using cars that existed. They changed them. So in 95, that information was well distributed among the researchers, particularly those who are working on algorithms that are relevant to that feat. The public wasn't interested in that because they don't have access to it anyways. It wasn't destined for them. The day we have the legislation allowing cars, self-driving cars to drive, and the day the big manufacturers like Ford, GM, Chrysler, and so forth have these cars, you will see it on every single ad. You'll see it everywhere. Now we know it because we have talks coming here. We had actually Sebastian Thrun, who was the a VP at Google, responsible of the Google car, was here and he gave us a talk. So people at U of A are aware of it. We may read it in some magazines, but it's not for the big grand public yet, even though it's working. You know, the first user of the Google car is a blind person. So he's a blind person, he goes in the car, he says, I want to go to this place, and the car goes and takes him there. By the way, think about this car. The day it'll become ubiquitous everywhere, it'll change our society. The cars change our society already. Before the cars, we lived in small hamlets, small towns. The car allowed us to live further away, create suburbs, bigger cities. Imagine now with a self-driving car, many things will change. One example, we won't need motels anymore because the driver who is tired and needs to sleep in this town and goes to the motel doesn't have to sleep anymore. He doesn't have to drive anymore. He sleeps in the car drives. So motels will disappear, possibly, or will be reduced. Maybe the suburbs will go further away, because now those who have to commute, if it's 1 hour commute, gee, it's a long time. But if I can commute for 2 hours while working and playing cards or doing something else while the car is driving, well, I can live far away. So maybe the cities will grow even bigger. I don't know, I'm just speculating like that. But just the fact that these changes will change completely our society. Yeah. I don't know if I'm answering your question or talking about something else, but we have to think about it now, today. We don't have to, we shouldn't wait till it happens, because the impacts are actually significant. Other questions?
So, how uniformly accessible do you think these things would be? Do you think we're talking about a terribly elitist society where rich people have all the things that we're talking about and the majority don't? Or do you think it will be a post-scarcity world where everything becomes remarkably cheap and everybody has it, and it's a completely democratic rollout? As you say, everybody who wants to upload their brain when they die can, and you know, where do you think this will end up in terms of this spectrum?
There are many possible models.
Yeah.
We don't know which model will be the right one, and which one will actually take place. It all depends if this is driven by government funding projects or driven by companies. Mm-hmm. If it's driven by companies, they are doing it only to make money. They're not doing it for the people. So I think it'll be a mixture. If governments will see interest for the people, they will do some of this stuff, but some others will be driven by companies. So we'll have a mixture. I definitely think that, for example, if we're talking about prostheses that will allow me to run faster, the government will say, well, we'll do it for free if your legs are cut walking on a mine, but if you choose to cut your legs, well, you pay for it.
Yes.
I don't know, it'll be a mixture like this.
I guess it's all in the timing, really. If we have an economic boom that happens to coincide with the technologic capability of doing many of these things, then they'll roll out for everyone.
No.
If the capability is there at a time when the economy is tanked, that is probably going to be very...
There will be other priorities for sure.
Yes.
Yeah.
Yes.
Agreed.
Are there other questions?
Don't you want to fly imaginarily in the future and ask questions? I don't know.
The flying car is interesting. You know, one of the articles that I wrote in the last year talks about what Shauna Pandya told us, is that there is now a flying car. You have to go to an airport, it lands and takes off on a runway, but it otherwise is a flying car, and it can drive on the road like a regular car.
But I personally believe we should not allow flying cars driven by humans. I will not go in a flying car driven by a human, because you can imagine the chaos. If we have chaos on, if it's driven by a machine, I'll trust it more.
Yeah, well, the movie, The Fifth Element, of course, if you look at the chaos there, yeah, it's very scary with all these flying cars. But the interesting thing, in terms of just how our society works, now there is a flying car. It's been through all sorts of tests. It actually exists now. And yet most articles still use the absence of the flying car as an obvious example that, you know, technology is not turning out the way we hoped. And people are so convinced of this idea that technology is not turning out the way we hoped.
The flying car is more problematic than the driverless car.
Yes,
The reason is that it poses a risk for our own privacy.
Right.
So if you're bothered by the cars driving in front of your car is one thing, but if they start driving on top of your, I mean, when you're having a party in the backyard on your deck, it's an issue.
Yes, yeah. No, I think there are many potential problems. Okay, we have 2 minutes. Isn't there somebody who has just a fantastic 2-minute question? Come on, you guys.
Sorry.
Yeah, I'm just wondering where we're at with building a brain interface with your...
A brain interface, there are brain interfaces. They exist, and I think in my next session or the session after I'll talk about it. There are brain interfaces and they're used for paraplegic, for example, and they are able to control, for example, a cursor on the screen just by thinking, and they move and select letters and they can type. They can even control their chair to turn left, right, stop. They exist, yeah. They're still rudimentary, and the game industry is particularly interested in that. There's the military industry and the game industry and the healthcare. And the game industry now is investing a lot because, well, they're games that you could be able to control by thinking and stuff like that. So the answer is yes, they exist.
Okay, we're out of time. Thank you very much.
Thank you.